An isotope is an atom with the same number of protons but a different number of neutrons from other atoms of that element. It just means that the atom has either gained or lost neutrons, which will change the atomic mass because atomic mass is protons plus neutrons. For any element, though, the number of protons will not change. If it is hydrogen, all hydrogens have one proton, regardless of whether it's an isotope or not. The protons are the identity of the element. The properties of an element are determined by the electrons. So regardless of the neutrons, whatever happens to the neutrons, the properties will be the same. The isotope, however, can be radioactive if the number of neutrons is too high, like it's gained too many neutrons, or it's too low, it lost too many neutrons. Instead of writing our atoms in a box like you see on the periodic table, we can use a different method. We can write the element symbol, then the atomic mass, then the atomic number. Or you can write the element name dash the atomic mass. So we might write something like helium, which has atomic mass of 4, atomic number of 2. We could also show it as helium dash the atomic mass, helium-4. We need to do this because not all heliums are the same. You can't just call it helium. It could be helium-4, helium-3. There are different atomic masses because there are different isotopes. But again, all heliums have 2 protons. This periodic table shows many of the stable isotopes for elements. Some elements, like hydrogen, have 2. Some, like titanium, have more than 2, and some don't have any. You can see from this periodic table that different elements might have different numbers of isotopes. This is their atomic mass. So boron, for example, can be boron 10 or boron 11. So far, when diagramming atoms, we've looked at the periodic table and looked for this number, the atomic number, and the atomic mass. We've been rounding that number to the nearest whole number. The reason we do that is because not all atoms are the same. The number of protons will not change. All atoms, for example, all carbon atoms, have the same number of protons, 6. But not all carbon atoms have the same number of neutrons, which means the mass of the nucleus, the atomic mass, could be different. There's not a single carbon atom in the entire universe that has an atomic mass of 12.011. That's an average. More specifically, it's a weighted average. To find the atomic mass, we need to know 2 things. What percent of carbon is carbon-12, what percent is carbon-13, and other ones too, like carbon-14. Of all the carbon atoms in the universe, 98.9% of them are carbon-12. So the majority are carbon-12. To that, we have to add the weighted average of carbon-13. So 1.1% is carbon-13. If you do 12 times 0.989, and to that you add 13 times 0.011, you work out an average mass of 12.011 atomic mass units. So no single carbon atom has an atomic mass of 12.011. However, the average, the weighted average, is 12.011. Let's diagram carbon-12 and then compare it to carbon-13. All carbons, regardless of whether it's an atom or an isotope, they all have the same atomic number, which is 6. That atomic number is the number of protons. So carbon-12 has 6 protons. If it has 6 protons, to be neutral, it needs 6 electrons. And of those 6 electrons, 2 are in the first shell and 4 are in the second shell. It has 4 valence electrons. The neutrons we get by taking the atomic mass, which carbon-12 has an atomic mass of 12. 12 minus 6 is 6. So we have 6 protons and 6 neutrons in the nucleus. Let's compare this to carbon-13, which is an isotope of carbon. That means it has a different number of neutrons, which makes the atomic mass different, which is why it's carbon-13, not carbon-12. But it is carbon, so it must have 6 protons. If it has 6 protons, it has 6 electrons to make it neutral, 2 in the first shell, 4 in the second shell. So you can see that the electrons don't change. More specifically, the valence electrons don't change, which means its properties are the same as carbon-12. What will change are the number of neutrons. Now the atomic mass is 13. So instead of 12 minus 6, we're doing 13 minus 6, which is 7. So carbon-13 has 7 neutrons. It just means that it gained a neutron at some point. It's a little bit heavier. Let's work out our first example. The common atom is hydrogen. There's also an isotope of hydrogen, but you can't call them both hydrogen. One we call hydrogen 1. The isotope is called hydrogen 2. It's slightly heavier than hydrogen 1. The symbols for hydrogen is H. But we can't use the same symbol for both. One's hydrogen 1, the other one's hydrogen 2. So what we do is a new method with the atomic number on the bottom, the atomic mass on the top. The atomic mass for hydrogen 1 is 1. The atomic mass for hydrogen 2 is 2. But they both have the same atomic number. All hydrogen has atomic number 1. That atomic number tells you the number of protons. All hydrogen atoms have 1 proton. Whether it's an isotope or not, it has 1 proton. If it's neutral, it has 1 electron. So does the isotope. They're the same chemically, just one is a little bit heavier. Even the electron dot diagram is the same. They both have 1 electron, 1 in the outermost shell. We put H with 1 dot. What will change is the number of neutrons. We figure out the number of neutrons by taking the atomic mass and subtracting the number of protons. The atomic mass is 1. There's 1 proton, so 1 minus 1 is 0. There are no neutrons in hydrogen. But in an isotope of hydrogen, there is, because the new atomic mass is 2 minus 1 proton equals 1 neutron. So somewhere along the way, this hydrogen atom has gained a neutron. 99% of all hydrogen atoms are hydrogen 1. Very few are hydrogen 2. Here's another example. Oxygen. There's a normal atom of oxygen. There's also a rare isotope. You can't call them both oxygen because they're different. So to separate them, we call them by their name and their atomic mass. The common one is oxygen 16. But there's also oxygen 17. The symbol for oxygen is in capital O, but you can't use that because they are different. So we have to put the atomic mass and the atomic number. We write the atomic mass on the top and the atomic number on the bottom. So normal oxygen has 16 and 8. The isotope, oxygen 17, has an atomic mass of 17, but it still has the same atomic number, which is 8. That atomic number tells the number of protons, whether it's an atom or an isotope. The electrons remain the same as well. It's still neutral. Even the electron dot diagram is the same. There are 8 electrons, 2 in the first shell, 6 in the second shell. So oxygen has 6 valence electrons. What will change are the neutrons. Atomic mass is 16 minus 8 is 8 neutrons in the common oxygen atom. The rare atom called the isotope has 17 minus 8, which is 9, which means this oxygen atom has gained a neutron somewhere along the way. Let's try another example. Lithium. There's the common lithium atom and an isotope of lithium. The common lithium atom has the symbol Li, 7 on the top, 3 on the bottom. That 7 is the atomic mass, which we can also use in the name, lithium-7. The isotope is called lithium-6. However, both have the same number of protons. The atomic number is 3. If there are 3 protons, there are 3 electrons to make it neutral. For both the atom and the isotope, there are 2 electrons in the first shell, 1 in the second, so there's 1 valence electron. All that's changing is the number of neutrons, which can affect the atomic mass. Lithium-7 has atomic mass of 7, minus 3 protons, gives it 4 neutrons. Lithium-6 is 6 minus 3, only has 3 neutrons. Here are 3 examples you can try. You're given enough information to figure out the rest of the row. The common atom in the first one is calcium. It's calcium-40. The rare isotope is calcium-42. The next example shows the symbol N with atomic mass of 14, atomic number of 7. The isotope for N has atomic mass of 15 and an atomic number of 7. The final example, you're given just the number of protons, which is 16. Use a periodic table to figure out what element it is, how many protons, neutrons, electrons there are. The isotope has 16 protons and 18 neutrons. From there, you can figure out everything else. Remember, the atomic mass is the protons plus the neutrons.